make sure you're done with your Mod 1 exam, because that is due tonight and you'll get locked out if you haven't finished that stuff yet. So that's kind of nice because we don't have any like real computational homework tonight like we did last time and tomorrow. So what I would like to do today is start by talking about what we worked on last time with parts 1 and 2. Maybe quickly go over some of these questions, and then if you want to talk about them in more detail, just ask me after I'm done, going over my notes here in a few minutes, and we can definitely go through each question step by step if you like, totally up to you. And then we'll talk about this new stuff. So in part 1, we had this information up here, and there were some questions that essentially said, convert all this to US dollars so we can see where we spent the most money. So for example, since these things are in euros, and this is per euro, in other words, these guys have euro on top, exchange rate has euro on bottom, we're just multiplying to get these numbers down here. And we do that essentially all the way across. You can utilize dragging to speed this up a little bit. And then at the end, we're adding those 3 numbers up to get sort of a grand total so we can compare the amount we spent in all 3 countries and see that we spent the most in Germany. Then there was like a quick follow-up question that essentially said, okay, you got 50 CNY, how much US dollars is that? That's the same question we just did, converting these CNY to US dollars. In fact, if you just wanted to like throw 50 up here in this calculator, we can get the answer right there. So nothing really new in that question. However, the follow-up where we're starting with dollars, that is a little bit different because we haven't started with dollars yet. Well, if you're starting with dollars and the exchange rate also has dollars on top, these 2 numbers can't both have dollars on top. You're not going to get cancellation that way. So we're actually going to take that guy and divide by this guy. So that's the first one where division is necessary. And that takes care of the majority of part 1. Then in part 2, we start introducing some percent change to these formulas. In other words, we're going to take these exchange rates that we start with, and we're going to change them by some percent to get a new exchange rate. So I think in the first example, it says shrink it by 10%. So if you saw me do an example a second ago, what you're essentially doing is figuring out what is 10% of this number. And then in this example, we're taking that away from that to get our final value. And in my notes in a second, I'm going to write down exactly what this formula looks like, but that's just the basics. And then the very last question, there's a whole bunch going on, but essentially we're starting with euros, converting to dollars, converting those dollars then to INR, figuring out what the exchange rate is between INR and EUR. So if we can get 22,000 for every 325, how many INR can you get per 1 euro? That's the idea there. Again, if you want to go through that in more detail, I can do that later on, just remind me. And then once we have this number, they ask us to shrink it by 17% to get that guy. Then they tell us to take our 19,000, subtract 100 INR fee to get that guy. And then last of all, if now our 325 euros results in only 18,000 INR after all these fees and whatnot, that's going to be our exchange rate if we compare these 2 numbers. If you're only getting 18,000 per 325, how many are you getting per 1? And then last of all, they want us to compare these 2 exchange rates that we computed in this question and say what percent smaller is this second one compared to the first. That's actually another percent change formula I would like to talk about in a minute or 2, but yeah, we'll circle back to that. And that was essentially all of part 1 and part 2, and that very quickly. And so like I said, if you want to see any of those questions a little bit slower, just remind me. What I'd like to do now is open up those notes I emailed out a little bit ago and walk through these, and then I'll let you get started on part 3 and 4 in the workbook. Okay, so let's start with this percent change stuff. there's two different versions of these percent change questions. The first is if you want to increase or decrease some number by a percent. So you take this old number, you change it, and then you get a new number. Well, the formula, there's a couple ways to write it, but if you simplify it and sort of algebraically manipulate it, this is, in my opinion, the easiest way to write it. You take that old number or the original number that you're dealing with, and you multiply it by 1 plus p%, whatever the percentage is, and you get that new number. Which means if we go back to like one of these over here, I can get this answer to part 2, number 1, by taking this guy, 1.1567, and multiplying it by 1 plus negative 10%. And that's where that value can come from. So it'll look like that, exactly like the formula I wrote down in my notes, original number in blue times 1 plus the percentage. And that's how you can either, increase or decrease a number by a percent. Increase uses positive percents, decrease uses negative percents. And here's a couple more examples. If you increase 30 by 10% or decrease it by 10%, those are the two numbers that get spit out. Now, in that very last question in part 2, it was a little bit different. They didn't give us the percent. The percent was the answer. We knew these two numbers from earlier in the problem, and they said, okay, 58 is what percent smaller than 70? So how do we figure this out? Well, if you take this formula up here and algebraically solve for p, you get this. And now since p is solved, you can plug in the things the new number and the old number, and you can get p. So in this case, since we're starting at 70 and shrinking to get 58, 58's the new number. And so you can plug it in just like I have over here, the new number, 58 that we've moved to, minus the original number, 70, in parentheses, all divided by 70. That is a negative 17.44% change, or a 17% decrease from 70 to 58. And that's how I would answer the last question in part 2. Next thing I want to talk about is the very first function that we are going to utilize in Excel. Functions are really nice things that we can utilize that simplify the math for us. So like, for example, let's say I wanted to add up all of these. I can do that. It's not that hard. It's just really annoying to type all of this out. And so it'd be really nice if we had a shortcut for this. And that's where something like a function comes in. So the way functions work is we don't type arithmetic. We don't use cell references or like numbers. We type words. And so all these functions are represented by words. This first one we're going to talk about is called the sum function. So you literally just type equals sum, and then you have to do one of 3 things to go into the function. You can type a left parenthesis. You can click on this number of all the, this word of all the other possible functions that pop up, or you can hit, you can use your arrows on your keyboard and hit tab. Now we're inside the function, and it wants us to put stuff in here. At this point, you just highlight all this stuff, you hit enter, and we're done. And that is the benefit of functions. They simplify these processes, so we're not having to start from scratch every time. It does a lot for us. So that's really useful. And in fact, if you want to, it would have been a little unnecessary here, but when you're adding up these lodging, food, and miscellaneous in part 1, you could use the sum function here and just, add up these 3 numbers. And it doesn't save you that much time, but it's good to practice. Okay, what else we got today? Today, we are going to be making our first graph when you get to part 4. So I wanted to do an example here with you to get you started. Let's say we have this small set of data over on the left, which is pretty similar to what you're going to use. Yours is just taller. And we want to create a graph of these first 2 columns. So all you do is you highlight the cells that you would like to graph. I want dates on my x-axis and these exchange rates on the y. So I'm going to highlight them like that. And then up at the top of the screen, instead of using the home tab, like we normally do for most of these buttons, we're going to go over to the Insert tab just right next to it, and we get a whole bunch of other different buttons. And what we're going to be looking at are these buttons here in this little charts section. You can technically hit recommended charts, but I like to actually use these smaller buttons nearby to be a little bit more precise. In this instance, and for this semester, whenever you have dates along the x-axis that we want to graph, I'm going to use this button here, which as I hover over it, says it's a line graph. And then it gives us a whole bunch of different options. Typically at this point, you know, if you don't really have a strong preference, I just pick the one in the top left. And there we go. There's our graph where we have dates along the bottom, exchange rates along the side, and we can see as time moves forward how the exchange rate has moved. Couple other tips with that. You might be thinking, okay, well, that helps if I just need to get these two columns, but what if I want the first column and the third column? I can't really do the same thing because now I'm highlighting all three, and that now it's graphing both, and that this middle guy is in the way. So here's a trick you can use, and there's a couple ways you can do this, but here's my personal preference. I'm going to highlight the first two columns, even though I want the first and third column, and I'm going to regraph. Whoops, that's not the one I want, but that actually wouldn't have mattered. I'm going to regraph these first two columns. Now notice, after I made the graph, I got these nice colors over here. I got this purple for my x-axis and blue for my y. What you can do at this point is you can hover your mouse over the right edge of this blue guy, not the corner, just the wall, and pull it to wherever you want. And then the graph redraws itself. And that's how to graph two columns that aren't adjacent to one another. A little trick you can use. Okay, what's one more trick we can utilize? Well, what if I go through and I graph these first two columns and I get this, and whenever this is like a homework question, for instance, it's always multiple choice, and I don't see this option in the multiple choice answers. Usually the reason for that is because it's formatted in a slightly different way, like it has different bounds on one of the two axes. So for example, let's say I wanted the y-axis to start at 1.08 instead of starting at 1. What you can do is take your mouse, hover over any of these numbers on the y-axis, and you double click, and you're going to get a picture kind of like that to pop up. So if I do it, I get that. We want to make sure we're on this weird 3 vertical bars area, and we have this section for bounds, minimum and maximum. And I'm just going to change the minimum to 1.08 and watch what happens to my picture. Instead of starting at 1, once I hit enter, it redraws itself and it starts at 1.08, essentially zooming in. So if the multiple choice options, in the homework all start at 1.08, this helps you, match when you get to the homework by making your graph look more like the options available. So it's something to think about. Okay, now what is more likely to happen for you today is you'll have something like this, where you have a whole bunch of numbers. And yes, it doesn't take that long to get to the bottom, but it's kind of annoying because you can miss sometimes. And okay, now I just ruined the whole thing. You have to start over. I want to show you a couple shortcuts to make this process a little easier. So first thing I want to point out is on your keyboard with your arrows, if you move the arrows, it just simply moves the cell that you've selected around. Simple enough. However, if you hold down Shift, it starts not only moving, but highlighting as you go, which is really nice. On the other hand, if I start over, and now instead of holding down Shift, if I hold down Control for Windows or Command on Apple, if I do like Control down, it jumps immediately to that last one at the bottom. I don't have to wait for it to scroll. And this is so useful when there's like 10,000 rows, because it'll take you a couple minutes to scroll through all that. It's awful. Likewise, if I want to go back up, I do Control up arrow, immediately to the top. Control right arrow, jumps immediately to the, the far right until it finds a break. That's how it works. Now, if I combine these two tricks, if I hold down Control and Shift, or if you're on Mac, Command and Shift, when I press Control Shift down, not only does it jump all the way down, it highlights as well. And at this point, let's say I want columns A and B. I don't want to do a Control Shift right because it'll jump all the way. So at this point, if I just do a shift and a right, it gives me one more column. And so it's a really quick way to highlight stuff, which is really nice. So here's one last trick for this page. If you highlight this and you go down and you make your graph here, the graph is way down here at like row 200 and you have to drag it up, really annoying. So if you start in the bottom left corner and highlight upwards, when you make your graph, now it's up here at the top where all your work is. Then you don't have to drag it anywhere. Kind of nice. Okay, so that's the first main new idea in part 4. Make a graph, manipulate it as needed. The other new idea is this thing called a correlation coefficient. And I'll show you how to compute it. It's actually pretty easy to compute, but I want to make sure you understand what we're computing. So a correlation coefficient is a number that's between -1 and +1, and it measures the correlation between two sets of data. Okay, well, what's a correlation? Well, a correlation near 1 means that as one set of numbers goes up, so does the other. So like if you measured all the hours you spent studying versus your grade in a class, and I did that for like hundreds of students, you would usually notice that the more people study, the higher the grades were. On the other hand, if the correlation coefficient's near -1, it's the opposite. As one set of numbers goes up, the other set of numbers goes down. So like if you have 1,000 students and you record all the days missed versus the grade, people that are missing 30 days of class, as that goes up, usually the grade goes down. Usually, not always. On the other hand, right in the middle is 0. Then there's like no relationship. So you got 1,000 people and you look at height versus grade. Usually there's no relationship there. There could be, but that'd just be purely coincidence. What else we got? We also say the closer it is to the endpoints, -1 or 1, the stronger it is. And the closer it is to 0, the weaker it is. So a correlation coefficient of -0.98 is stronger than +0.8. Okay, so it's this number. It measures if there's a relationship. How do we actually do this? Well, let's say I want to measure if there's a relationship between these two columns here. As one, I'm essentially saying, as one of these exchange rates goes up, does the other exchange rate go up? Is there some sort of connection between the two? So we're going to follow these steps here. This is our second function we're going to learn. It's the CORREL function. So if I start typing COR, it's literally the only function left. I can hit tab to have it type the rest of it for me. And now look at this little floating tooltip. It's telling me it wants array 1, array 2. An array is just a set of data. And all we're going to do is highlight the first column of numbers, type a comma, and highlight the second column of numbers. If I hit enter, there's my number between 0 and 1. That's a really big number. It's pretty close to +1. So that's a strong relationship. As this one went up, so did this one. So maybe there was a link going on there. Also, when it asks you to graph correlation coefficients, like to see if there's a relationship between these two, for example, you are not going to graph the dates. And because we're not going to graph dates, we're not using a line graph. We're instead going to use this guy. It's called a scatter plot. And it looks like that. So one way you can see a strong correlation coefficient, this is a strong one, is that if you look at the scatter plot, all these dots kind of lie on a line, which means, as one of the numbers, the x's go up, so do the y's. So this is a strong positive correlation coefficient.